Hello and welcome to my YouTube channel ChemWis. In this video we are going to learn Sommelet-Hauser rearrangement. In this reaction, a benzyl quaternary ammonium salt in the presence of sodamide in liquid ammonia converts to ortho-alkyl derivative of N,N-dialkyl benzylamine. Thus, overall, in this reaction, benzylic group gets converted to ortho-alkyl group, quaternary ammonium group gets converted to tertiary benzylamine. To make the product of Sommelet-Hauser rearrangement without knowing mechanism, just break this benzylic CN bond to get these fragments and then connect the tertiary amine residue with the ortho position through the alkyl group having alpha hydrogen. Mechanism of Sommelet-Hauser rearrangement. Benzylic proton of benzyl quaternary ammonium salt is acidic and sodamide is a base. Deprotonation of benzylic proton by sodamide like this produces benzylic ylide. This benzylic ylide is in equilibrium with a second ylide that is formed by deprotonation of one of the ammonium alkyl groups. The second ylide is present in much smaller amounts. It undergoes 2,3 sigmatropic rearrangement like this to produce non-aromatic intermediate, which undergoes aromatization like this to produce rearranged Sommelet-Hauser product. Now let's have few examples. The simplest example is the reaction of benzyl trimethylammonium iodide with sodamide in liquid ammonia. As I have discussed in the beginning, to draw the product, break this benzylic CN bond to get these two fragments and then connect the tertiary amine with the ortho position through one of the three methyl groups. Thus, the product will be N,N-dimethyl-1-orthotolylmethenamine. Reaction of 1,1-dimethyl-2-phenylpiperidinium iodide with sodamide in liquid ammonia. Here also, to make the product, break this benzylic CN bond to get this structure and then join one of the two methyl groups with the alpha carbon of benzene. Thus, this will be the structure of product. Another example. In this example, reaction of cesium fluoride leads to the removal of TMS group to produce ylide, which undergoes 2,3 sigmatropic shift to produce this non-aromatic species. Aromatization of this non-aromatic species like this gives product. This is another similar example where reaction with cesium fluoride will give ylide, which will undergo 2,3 sigmatropic shift to produce non-aromatic species, aromatization of which like this will give this tricyclic product. Let's have the last example of this lecture. Here, potassium tert-butoxide abstracts the most acidic proton, which is alpha to ester, to produce this ylide, which undergoes 2,3 sigmatropic shift to produce the non-aromatic intermediate. Aromatization of this intermediate like this will give this product. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much for watching this video.